Bismillahirrahmanirrahim. Dear students, our topic is galvanometer. How to convert a galvanometer into an ammeter. As we know that galvanometer is used to detect the current in a circuit, and ammeter is a device that is used to measure the current. Ammeter is connected in series in the circuit. We know also that galvanometer is sensitive. That is, if a small current passes, it shows a full deflection. So large currents cannot be measured by galvanometer. Second, that large currents they will melt they will produce heat and melt the coil and damage the galvanometer. So how we overcome these two limitations? For that, these two overcome, we connect a small resistance across the galvanometer. So if G is the galvanometer resistance, we connected a small resistance across it. So when current passes through, it is connected in series. Most of the current passes through the shunt resistance. This small resistance is called shunt resistance. And second, when a small current passes through this, it will not change. It will not make the difference. So it will be close to the actual value of the current through the circuit. As we know that these two resistances, they are in series, so the resultant resistance will be equal to, it will be G into R divided by G plus R. Because in parallel, these are two in parallel resistance, so we know that resultant in parallel is 1 by R. P is equal to 1 by R1 plus 1 by R2. It is G and R, so it is 1 by G plus 1 by R. So you cross multiplication, we will get G plus R by RG. R inverting, we will get R is equal to GR plus G plus G plus R. Since R is very small, so G plus R is equal to G. So it is GR by G and S. So practically the combination, so that the ammeter has very small resistance. Combination is a small resistance, so it will not change the value of the current when the current passes through this combination. And current sensitivity of galvanometer, we know it is a deflection per unit current. So it is we know that a deflection is N A B I by K, where N is number of turns, A is the area of the coil, and B is the magnetic field, where I is the current and K is the constant. So it is the galvanometer constant. So we will get pi by I is equal to NAB. So we will see that if we want to increase the sensitivity of this, we have to increase the number of. Now if Ig is the current through the galvanometer resistance and I minus Ig through the shunt, then the potential difference across shunt is equal to potential across the galvanometer. So I minus Ig into S is equal to Ig into G. So shunt resistance is given by Ig into G divided by I minus Ig. So if we know the galvanometer resistance and the current, maximum current for which it gives the deflection, we can calibrate an ammeter of a given range. You have an example here. We have a galvanometer resistance of 12 ohm, 15 ohm, which gives full deflection for a resistance of 2 milliampere. We have to calculate the shunt resistance. So we are given this Ig is 2 milliampere, that 2 into 10 is minus 3, and G galvanometer resistance is 15. So we substitute. If we want to convert it into a range of 0 to 5, so maximum current it should measure should be 5. So we substitute, it is 2 into 10 raised to the power minus 3 into G, that is 15, divided by I minus, that is 5 minus 2 into 10 raised to minus, that is 0.002. So we substitute, we will get the answer. Now second, how to convert a galvanometer into voltmeter. As again we know that voltmeter is used to measure, it's connected in parallel in the circuit to measure the potential difference. So it must draw a small current so that it cannot disturb the potential of the circuit in that part. For that we need that a large uh, resistance connected in series with the galvanometer, so the total resistance increases and a very small current passes through the galvanometer, and it does not, the main current passes through the circuit and the potential difference is not changed. Voltage sensitivity, so the total resistance of this galvanometer, in case it is G plus R because they are in series, so voltmeter resistance will be equal to G plus R, and volt sensitivity is equal to reflex per unit voltage, that is phi by V is equal to NABI by K by V, where NABI K is equal to phi, so I by V is equal to R, so it NAB KR. The if V is the maximum value of the potential difference to be measured, and resistance R is connected in series with the galvanometer, and galvanometer shows full deflection for current Ig, then V is equal to potential is equal to potential across the galvanometer, that is Ig, current into the resistance of galvanometer, that is G plus R. So Ig is equal to V by R plus G, and R is equal to, it is V by Ig minus G, V by R G minus G. So you can see now we can calculate the resistance to be connected in series in case we want to make a galvanometer, convert a galvanometer into a voltmeter. For that, if we have a galvanometer of resistance 12 ohm and it shows the difference for 3 milliampere, how will we convert it into a voltmeter of range 0 to 18? For that, you know that we are given G is equal to 12 ohm, Ig is equal to 3 into 10 to minus 3 ampere, and maximum voltage to be measured is 18, so V is equal to 18, so R is equal to 18 divided by 3 into 10 raised power minus 3 minus G. So we calculate, we will get the resistance. So that way you try other examples from your textbook, and you will have some assignments on numerical problems on this.